Solve the quadratic inequality 3x squared plus 12x less than negative 12. Give the answer using interval notation. If there are no real solutions, enter DNE. Step 1 is to write the quadratic inequality in standard form, which means we need to add 12 to both sides of the inequality, which gives us 3x squared plus 12x plus 12 less than 0. Step 2, determine the critical points, which are the zeros or solutions to the related quadratic equation. So now we solve 3x squared plus 12x plus 12 equals 0. Let's solve by factoring. Recall the first step is to factor out the greatest common factor, which in this case is 3, giving us 3 times the quantity x squared plus 4x plus 4. Let's see if we can factor further by factoring the trinomial into two binomial factors. The factors of x squared are x and x. The factors of positive 4 that add to positive 4 are positive 2 and positive 2, giving us 2 factors of x plus 2. Let's write this as 3 times the square of x plus 2 equals 0. Notice the left side is 0 only when x plus 2 equals 0. Solving for x, we have x equals negative 2. So here we only have one critical point, which we now plot on the number line as either an open point or closed point based upon the original inequality. Because the inequality is less than, not less than or equal to, we plot negative 2 as an open point. The open point indicates negative 2 is not part of the solution. If we subbed in x equals negative 2 in the inequality here, the left side would be equal to 0, and 0 less than 0 is not true. Step 4, we now select test values or test points from the intervals that we created by plotting an open point on negative 2. To the left of negative 2, we'll use x equals negative 3. To the right of negative 2, let's use x equals 0. And now we substitute the test values into the inequality to see whether the inequality is true or false at these values. If the inequality is true at the test value, the entire interval is true. If the test value is false, the entire interval is false. We can use the inequality in the original form or in standard form, or we could actually even use it in factored form as well. So let's use the quadratic inequality in factored form, meaning the form of 3 times the quantity x plus 2 squared less than 0. Recall this is the factored form of the quadratic expression. And now we'll test x equals negative 3. We really only care about the sign of the left side because we're comparing to 0, but I'm going to go ahead and calculate the exact value on the left. When x is negative 3, we have 3 times the square of negative 3 plus 2, which is the square of negative 1, which is equal to 3. And 3 less than 0 is false. 3 is not less than 0. We mark the left side as false. And now we test x equals 0. When x is 0, we have 3 times the square of 0 plus 2, or the square of 2, which is 12. 12 is also not less than 0. So the right side is also false. So analyzing the number line, the interval on the left is false, the interval on the right is false, and we have an open point at x equals negative 2, meaning negative 2 does not satisfy the inequality, which indicates we have no solution. Which is the directions say in the homework system, we enter DNE. Before we go, let's verify this by analyzing the graph of the related quadratic function. Let's consider the quadratic inequality in this form here. To check it graphically, we graph the function f of x, or y, equals 3x squared plus 12x plus 12, which is shown here on the right. Because this is the graph of y equals 3x squared plus 12x plus 12, and we're looking for the solution of 3x squared plus 12x plus 12 less than 0, we're looking for the part of the graph where y is less than 0, meaning where the graph is below the x-axis. Notice there are no points on the graph that are below the x-axis, which is why there is no solution to the quadratic inequality. At x equals negative 2, notice the y value is 0, but when the y value is 0, notice the 0 less than 0 is still false, again giving us no solution. I hope you found this helpful.